In this proof of concept, an attack simulation was conducted on Ubuntu and Windows virtual machines within a secure and controlled environment. Caldera was installed on the Ubuntu VM to automate adversary emulation. Installing Caldera offline. Internet-connected machine. On an internet-connected machine, refresh the package lists from the repositories and create a structured directory for downloading dependencies. Download and install VM tools and its dependencies. This will enable copy and pasting and dynamic resolution. Reboot the VM. Download Python 3 pip and its dependencies. Install the packages in the following order. Verify Python 3 pip installation. Download and install Chrome. Verify installation. Download and install curl. Verify installation. Download and install JQ. Verify installation. Download UPX. Download and install Git. Verify installation. Download and install Node.js. Verify installation. Download and install NPM version 11. Verify installation. Download and install Go. Verify installation. Clone and prepare the Caldera repository's master branch. This process may take some time. Navigate to the directory, Caldera, plugins, atomic, data. Clone and prepare Atomic Red Team repository. This process may take some time. Fetch Golang dependencies for the Sandcat plugin. Fetch Node.js dependencies for the Magma plugin. Edit Caldera's requirements.txt with the following changes. Make a directory for Python dependencies and download all dependencies listed in the requirements.dev.txt and requirements.txt into the Python_deps folder. Compress all dependencies for transfer. Transfer Caldera offline.tar.gz to the air-gapped VM using a USB drive. Installing Caldera offline. Air-gapped environment. On the air-gapped VM, make a directory called Caldera offline and extract the transferred archive. Install the Python 3 pip packages in the following order. Verify installation. Install Google Chrome and verify installation. Install JQ and verify installation. Install curl and verify installation. Install UPX and verify installation. Install Node.js and verify installation. Install NPM version 11 and verify installation. This process may take some time. Install Go and verify installation. Restore Golang dependencies. Restore Node.js dependencies for the Magma plugin. Install all dependencies listed in requirements.dev.txt and requirements.txt. Add the .local bin directory to your path. Running Caldera. Navigate to the Caldera directory and launch the server. Wait until you see all systems ready. This process may take some time. The login credential for the web interface can be found in the directory caldera conf local.yaml. On Firefox, navigate to localhost port 8888. Use the red user's credential to log in. At this stage, the web interface can only be accessed from the local machine hosting Caldera using localhost as the URL. Although it is possible to open the web interface from another device on the same network by using the machine's IP address, the login page will be unresponsive. To resolve this issue, exit Caldera by pressing Ctrl+C. Edit the local config file. Change app contact HTTP an app frontend API base URL to point to the Caldera VM's IP address. Edit the Magma plugins environment file. Change the URL to point to the Caldera VM's IP address. Rebuild Caldera with -- fresh parameter. Wait until you see all systems ready. This process may take some time. The newly generated login credential for the web interface can be found in Caldera's local config file. From the Ubuntu VM, verify that you can log into Caldera's web interface using the red user's credentials, with the Caldera VM's IP address as the URL. Likewise, verify that you can log into Caldera's web interface using the red user's credentials and the Caldera VM's IP address from the Caldera VM itself. Introduction to Caldera. Configuring abilities. Navigate to Abilities and search for CheckPython. Under Executor, enter following details for Linux and Windows. Click Save. Search for Check Chrome, then repeat the similar process. Search for Check Go, then repeat the similar process. Navigate to Agents and click Configuration. For Bootstrap abilities, add CheckPython, CheckGo, and CheckChrome. For Deadman abilities, add Clear Logs. Click Save. Deploying Linux Agent. Click Deploy an Agent. Select Sandcat as an agent. Select Linux. Copy and paste the commands into the Linux client. After running the commands on the Linux client, confirm that the agent is visible and its status is alive in the Caldera web UI. For deploying Windows Agent, select Windows as the platform. Copy and paste the commands into the Windows PowerShell. On Windows Client, disable Windows Defender. Paste the commands into the PowerShell terminal of the Windows client. Confirm that the Windows agent is visible. Verifying access to agents. Navigate to Access and select your Linux and Windows agents. You will see the actions defined in Bootstrap and Deadman abilities completed on each client, along with the status. Creating a new adversary profile. Navigate to Adversaries. Click New Profile, then edit the adversary name and description. Click Done. Click Add Ability. Search and select CheckPython. Add the abilities for CheckGo and CheckChrome. Creating custom abilities. Navigate to Abilities and click Create an ability. Put following details for the Run LinPEAS ability. Add Executor and put following details for Linux and click Create. Repeat the process for creating an ability for WinPEAS. Since we configured our agents to download LinPEAS and WinPEAS from the Caldera VM's web server, we need to download the tools and host them on a web server. On the Caldera VM, connect to the internet and download LinPEAS. Then, modify its permissions to allow execution by running the following commands. Download WinPEAS and output it as winpeas.exe. Start a Python web server to serve the downloaded tools. Adding custom abilities. Navigate to Adversaries and add the Run LinPEAS and Run WinPEAS abilities to your adversary profile. Click Save. Creating an operation. Navigate to Operations and click New Operation. Name the operation and select your newly created adversary profile. The default setting for obfuscators is plain text, but other options, such as base64, are available. Click Start. The operation will start and execute the abilities we configured on the Linux and Windows agents. Wait until the operation returns a status for all abilities. To add a manual command, click Manual Command, select the agent, choose the executor, enter the command, and click Add Command. For example, to view the output of LinPEAS on an Ubuntu agent, enter the following command. Once the status shows success, click View Output. Generating an operation report. The Run LinPEAS and Run WinPEAS abilities cause JSON report errors. To demonstrate report generation, the Red Eagle v2 adversary profile excluding these abilities was used in the Cyber Defense Kit v2 operation. Navigate to Operations and click Download Report. Use the JQ to view the JSON report by running the following command. Search for Chrome by typing /Chrome. Generating a PDF report. Navigate to Debrief and select your newly created operation. Click Download PDF Report. Select report sections that you want to include, then click Download. This generates a well-formatted PDF report. Generating a layer for MITRE ATT&CK Navigator. Click Compass plugin. Select your newly created adversary profile and click Generate Layer. This will automatically download layer.json file. Click Open Existing Layer, then select Upload from Local. Choose layer.json and dismiss the warning for an outdated layer. This highlights the discovery techniques in MITRE ATT&CK Navigator used by our newly created adversary profile. In this proof of concept, we installed Caldera offline in an air-gapped Ubuntu environment, deployed Linux and Windows agents, and created custom abilities using LinPEAS and WinPEAS. We explored core features, executed operations, and generated reports, including JSON, PDF, and a MITRE ATT&CK Navigator layer. Caldera is a powerful tool for adversary emulation and security automation, making it invaluable for testing defenses, training blue teams, and refining red team tactics. For more details, refer to the Cyber Defense Kit documentation.